So this time, let us go ahead and consider a tube of length L. It is given that the diameter of this tube is 1.5 centimeters. Water flows through the tube at a velocity of 1 meter per second. The inlet temperature would be 50 degrees Celsius and the exit temperature is 65 degrees Celsius. The wall temperature would be maintained at 90 degrees Celsius and we would have to determine the length of the tube. So this would be the illustration for the problem. As you can see, water enters the tube at the velocity of 1 meter per second. Inlet temperature is included in outlet temperature as well. And what we would have to find out would be the length of the tube. As you can see, we could go ahead and compute for the bulk temperature since inlet and outlet temperature is given. So the bulk temperature would be 57.5 degrees Celsius. And this would be the temperature that we could use to calculate the properties of water. So as you can see, it is included in the solution. The density would be 988.886 kilogram per cubic meter. K would be 0.6451 watts per meter Kelvin. Heat capacity would be 4179.1554 joules per kilogram Kelvin. And lastly, the viscosity would be 4.947 times 10 raised to negative 4 Pascal second. Using all this information, we would be able to find the Prandtl number based on the bulk temperature, and that would be 3.2048. So at inlet, the temperature is 50 degrees Celsius. Since we are given the velocity at the inlet of the pipe, which is 1 meter per second, let's go ahead and determine the density at 50 degrees Celsius. So that would be 992.1936 kilogram per cubic meter. Using this information, let's go ahead and compute for the mass flow rate. That's going to be 0.17534 kilogram per second. And using the information that we have just calculated, since mass flow rate is usually constant through the tube till the outlet, we could go ahead and compute for the mean velocity. That's going to be 1.0034 meters per second. So since we already have the mean velocity of water, we could go ahead and compute for the Reynolds number. That's going to be 30,985.894. And this value indicates that the flow is turbulent. Since the value for Prandtl number is greater than 0.5 and the flow is turbulent, we could use the correlation of Nielinski. So first of all, let's go ahead and compute for the friction factor. That's going to be 5.8636 times 10 raised to negative 3. And the Nusselt's number, according to the Nielinski correlation, that would be 155.9086. Another formula for Nusselt's number, aside from the correlation for Nielinski, this is going to be h bar times d over k. Since we have the value for d and k, we could go ahead and compute for h bar. That would be 6,705.109 watts per square meter Kelvin. And since we have a constant wall temperature, we could use this relationship and we could calculate for the value of the length. We have all this information, let's go ahead and substitute, and the length would be 1.090 meters. That's all.